Assalamualaikum warahmatullahi wabarakatuh, and hi. So we will continue our lessons about alkane. So today we will learn about the source of alkane, physical and chemical properties of alkane. Okay, so source of alkane mostly come from petroleum and natural gas. Okay, if the source of alkane come from natural gas, the molar mass usually are low in molar mass. Meanwhile, for petroleum, it consists of more complex alkane. Next, we go to the physical properties. We will learn about two physical properties. First, boiling point, and second, solubility. In boiling point, we will learn the difference between straight chain and isomeric alkane. Meanwhile, in solubility, we will learn the solubility of alkane in water and inorganic solvent. Okay. For straight chain alkane, in general, the molar mass of alkane increase with the increase of carbon chain. Okay, so from this table, we can see that the increase in the number of carbon. Okay, for example, for methane, it has one carbon atom. Okay, the boiling point is negative 161. It has very low boiling point compared to decane that consists of 10 carbon atom. The boiling point is high, that is 174 degrees Celsius. So we can conclude that the number of carbon increase and it makes the boiling point also increase. Okay, so we can see that from this graph. Okay, the graph shows the number of carbon atom and also boiling point. As we can see here, when the number of carbon atom less than 4, alkane exists as gas at room temperature. Meanwhile, if the alkane has 5 carbon atom and more than 5 carbon atom, the alkane exists as liquid in room temperature. Okay, for boiling point of straight chain alkane, it increases with the increasing molecular size. And the factor that affect molecular size is molar mass and also the number of carbon. The reason why, first, as the number of carbon increase, the molecular size, weight or molar mass will increase. When the molar mass increase, this will make the London dispersion force between molecules become stronger. So when the London dispersion force becomes stronger, we will require more energy to overcome the London dispersion forces. Next, we go to boiling point of isomeric alkane. From the table below, the number of carbon atom, all of the isomeric alkane has 5 number of carbon atom. However, the difference between these 3 molecules is the number of branch. For pentane, it is a straight chain alkane. Meanwhile, for 2-methylbutane, it has 1 branch. For 2,2-dimethylpropane, it has 2 branch. So the boiling point for pentane is highest, that is 37 degrees Celsius, compared with 2,2-dimethylpropane that only has boiling point 9 degrees Celsius. So why? Even all of these 3 molecules has 5 carbon, but the boiling point is different. This is because boiling point of alkane decrease with more number of branching. So when the number of branching increase, the contact surface area will decrease. So this is the illustration. For example, if we have straight chain alkane 1, 2, 3, 4, 5. So this is the contact area between molecule. So we can see that the contact area of the molecule is larger compared with the, for example, 3,3-dimethylpropane. So this is propane. So the contact area is smaller. So when the contact area is small compared to the straight chain alkane, this will make the London dispersion forces become weaker compared to the straight chain alkane. So attraction of London dispersion force between molecule is weaker when the number of branch increase. Therefore, less energy is required to separate molecule from one another. That's why branching will decrease the boiling point, because when the surface area in contact is small, so the London dispersion forces also become weaker. Okay, so we go to the practice. Okay, so arrange the following alkane in order of increasing boiling point. So the first question, okay, we can see that we have different molar mass and also different number of carbon, but all of this alkane is a straight chain alkane. Okay, and the second one, okay, we have, for example, hexane 2,2-dimethylbutane and 3-methylpentane. Okay, for question 2, all of these 3 molecules have 6 carbon. However, the boiling point is different because this one has branch. Okay, so this is the answer. You also can try. Okay, so we go to solubility. Okay, alkanes are insoluble in water but soluble in non-polar solvent such as benzene, carbon tetrachloride, chloroform, and other hydrocarbon. Okay, this is because alkanes are non-polar molecule. Okay, so when it is non-polar molecule, it cannot form hydrogen bonds with water molecule. However, alkanes are soluble in non-polar solvent because it can form London dispersion force with the molecule of the solvent. Okay, so we go to the chemical properties of alkane. Okay, first, alkane has no functional group, so it is mostly unreactive. Okay, so for alkane, it can undergo combustion. So for combustion of alkane in excess oxygen, it will produce carbon dioxide and water. Okay, if alkane burns in limited supply of oxygen, it will produce carbon monoxide and water. Okay, remember, carbon monoxide is a dangerous gas. It is colorless and odorless. And then, if the alkane burn in very limited supply of oxygen, it will produce carbon and also water. Okay, so this is the practice. You need to try to write a balanced chemical equation for the combustion of alkane in these 3 situations. First, in excess oxygen, second, in limited oxygen, and third, very limited oxygen. Okay, that's all. Thank you. Have a good try.